we continue looking into testing process through the dimension of time and agile software development. So looking at the process models from waterfall to agile. In the figure in the x-axis we have the functionality of the system. So the more the functionality, the more it's on the right. Then we have the time dimension going from top to bottom. So we can see that the waterfall model, the idea is that all requirements first, all design second, all implementation third, and all testing as the last phase. So then later on some incremental process models came along that say, well, you do it in 3 increments where you do requirements, design, implementation, test, and then you repeat it as many times as needed. And then we have the final figure that states that design, implementation, and tests go side by side at the task level as it does in agile processes. And we can think this in terms of time horizons. So we have the task level time horizon that is the smallest. During that time horizon you try to complete a single task. Then the next time horizon would be sprint or iteration level time horizon. So here we have, for example, the Scrum, which develops a sprint backlog, that is the set of requirements that will be implemented in the sprint by pulling them from the product backlog. And then there is a 30-day sprint, and then it produces a working increment of software. And this is depicted here with this arc representing the 30-day time horizon. And these red arcs here on the bottom represent the task level time horizon. Obviously we try not to communicate that there would only be 5 tasks inside a single sprint, so there could be numerous. They are just smaller than the sprint level. And although the sprint produces a working increment of software, we might not want to release that software every time. So it might just be for internal use or for demonstrating the customer. So we would have a collection of sprints and put them inside a time horizon of a release project. So this would imply that as we have 30-day sprints, then this would be a release project that would end in 4 months. So one would release the software every 4 months and then deliver it to the customer. As there are big differences in the processes between agile and sort of waterfall-based development, so testing in the agile also has to be a bit different. We have to think testing as part of each development task. We cannot think that testing would be phase at the end. This will not work. In agile software development, software is developed incrementally, so it also has to be tested incrementally. In agile development, you have rapid time box development. And what does a time box mean? Time box means that you have a certain amount of time to do something, and no matter what, the deadline will not be altered. So there are time-boxed releases and time-boxed sprints, and the deadlines are not flexible. However, what is flexible is the scope. So you can reduce the number of features within a sprint or within the release project, but the deadline cannot be altered. And testing becomes very important as it provides information for scoping. So if it seems that there are already a lot of features that have a lot of bugs, then this informs that the scoping should be reduced. Otherwise, the quality of the end product will be too low and it cannot be released to the customer. And this also implies that testing has to be done early so that you have early information on what type of level of quality you are going to release and how much scope can you actually fit inside the project. So designing testing process in agile development, then one has to go through thinking through the time dimension. In the lowest level we have automated regression testing. So automated unit tests, daily builds, and automated tests. And they are represented by these blue arcs here that are connected to each task. So for each development task one would develop also a unit test, and then this unit test will become the part of the unit testing harness that is executed daily or nightly against the current build. One should also consider having a stabilization phase or an increment. So it is represented by these blue areas here. So for each sprint, you might devote time in the end to stabilize the increment, to ensure that everything works. So you would have a feature freeze, so no new features to the source code, and you would do testing and debugging and defect resolving at the end of each sprint. This could also happen at the end of the release project. So if you assume that you have a release project consisting of 4 sprints, so this would be 1 month, 2 month, 3 month, and then on the 4th month you would devote the entire sprint to finalize the testing and to conduct quality assurance. Finally, you might consider having a separate system testing altogether. So you would have an independent testing team. And here it already goes into how you organize testing in terms of teams. So we are not talking strictly about processes. So the development team would come up with the sprint that produces a release that would be then handed over to testing team that would conduct the testing in the next sprint. And you would have sort of development sprints, and then they would be followed by the testing sprint. And of course the development team would jump to the next development sprint, and then the testing sprints would be one sprint behind the development. And of course you could combine all this. So you would have the daily automated unit tests, you would have towards the end of the sprint the sort of stabilization debugging, you could have the separate testing team, and then you could have also the separate testing increment here in the end. And this would be followed by one more testing sprint that is currently missing from the figure. So this would be the combined approach. In Agile, one should think the quality assurance through the time horizon. So we have the task time horizon, where the quality assurance is part of each development task. For example, unit testing represented with the blue arcs here. You would have the increment or the sprint level time horizon. So there you would think, what quality assurance tasks are part of each sprint? What quality assurance checks we need to complete this sprint? And one could think that functional level system testing would be something that needs to be completed through the sprint. And it should be, functional systems should be delivered at the end of each sprint. Then on the release time horizon, it's quality assurance activities that we need to complete the release, so we can really put it out to the customer. And this could be something like performance testing, for example. Of course, it is a very good idea to keep this performance testing going on all the time. But if you are doing releases for internal purposes or just for demonstration purposes, then the performance might not be so important. So when you need the performance is when you release the product to the customer. Of course, there is the possible problem here that if you find a performance problem here on the last increment and you have some type of architectural flaw that is causing the performance issue to exist, and it might be very difficult to fix it at this very late phase. Anyway, so the point of this lecture is to think about quality assurance in different times. So what is part of each task, what is part of the sprint, and what is part of the whatever time horizon you have that is larger than the sprint. Is it release or whatever that is? So to summarize, Short sprints and rapid release pace does not allow for long and unpredictable testing phase that is at the end. The schedule is fixed and the scope is flexible. So in order to prioritize and know how much scope can you complete, the level of quality must not be revealed only at the end. So this would be a very big problem. So one should aim towards the task level quality assurance. So the more one leaves for the later phases, the higher the risks are. So the task level testing is really the test early, the test often approach. And the task level quality assurance is also the safety net in the testing triangle. So it really is the unit testing level here. But it is simply in this sort of time-based view, it is tied to each task, and it is tied to the daily activities of the work and not to different phases, as it was done in the sort of waterfall development where everything was completed, and after the coding you started the unit testing phase and so on. Here it's part of each task, so it's a different viewpoint. So previously we had these three dimensions for software testing: quality attribute viewpoint, accessibility viewpoint, white box, black box, and then we had the testing level viewpoint: unit, integration, system, and well, for consistency I changed the highest level of acceptance testing to system of systems testing, because sort of breaks the logical unit of the system size. So it was sort of coming from the different dimensions. But it could also be acceptance testing. So now we can introduce maybe improved Y dimension. We could think the Y dimension in terms of time. So this could be, quality assurance tasks that are done daily, weekly, monthly, yearly. Or we could think it in terms of the size of the work. So for each task, for each iteration, for each release, for main release, we do these quality assurance activities. But no, we cannot really claim that this would be the improved Y dimension. They are simply different dimensions that you might or might not care about. So currently there are 5 dimensions here, and as you can see, it is becoming very difficult to draw a figure like this with 5 dimensions. We humans cannot really understand it, so I'm just going in for the table. So the dimensions for testing, we could have the quality attributes, we can have the coverage-based approach, white box, black box, the system structure, unit, integration, system of systems. We can have the frequency or the time horizon based, so what activities we do daily, weekly, monthly, yearly, or finally the size of work. So quality assurance activities that are part of each task, each feature, each sprint, each release, each main release. So currently we have 5 dimensions for the testing process. And the way you start to reason about what type of testing to do in which time dimension and which system structure and so on, now it really starts to become very complicated, because at this level everything is connected to everything. So for example, the improved Y dimension, it might not even make sense to have like yearly and monthly quality assurance plans. So what quality assurance do you do each month? As this depends on how often one releases or deploys code to the production environment. And there can be quite big differences between the companies. So for example, it is quoted in one of the articles that I will put to the course Moodle that Netflix releases software 4,000 times a day. So 4,000 deployments to production environment. And in the other extreme, we did a study where we looked into the release frequencies in some Finnish companies, and we found that there was a medical embedded device producer that did 1 release per every 18 months. And this does not try to communicate that more releases or more deployments to the production is better. This is highly dependent on the domain, on the requirements, what type of hardware you are using, and so on. So it's not fair to say that, okay, Netflix is much better than this company. It could be that there are very strict medical regulations that require very, very thorough testing, very thorough certification, and this process alone can take up to several months. So it is not possible or not even feasible for them to deliver new software versions on 4,000 times a day. And on the other hand, if we think about the defects and their consequences in these different environments. So if Netflix makes a mistake and something doesn't work well, your movie does not play. So in the end, it's a minor inconvenience, although it's a minor inconvenience to thousands of people. But still, it's not so critical. Whereas in the medical device business, if the medical device malfunctions, then people could die.